Welcome back to Control Plus Concept YouTube channel. Before moving on with the questions, we'll first look at a few operations that can be performed on a language. First one is union. L1 you can have, since languages are sets, you can perform union operation on sets. So this means that the element which belongs to this union is either an element of L1 or an element of L2. Similarly, intersection can also be performed. Then difference L1 minus L2. So if X is an element of L1 minus L2, this implies X1 is an element of L1 and X1 is not an element of L2. Another operation is languages themselves can be concatenated. This implies a set XY where X is an element of L1 and Y is an element of L2. Now mind you, this is not the same as L1 cross L2. Here it's not string concatenation that happens, but it's a set, a pair X comma Y, such that X is an element of L1 and then Y is an element of L2. Another operation is similar to how we raised a word to n. We can do the same for a language. Here again, this means the language is repeated n times. Now a language which is repeated 0 times would have just lambda in it. Language 1 is the language itself. Now L2 would be LL and so on. Now L star is also present, so L star is L0 union L1 union L2 and so on. Similarly, L plus. So the difference between plus and star, as we know earlier, is lambda wouldn't be there. So lambda is L0. So if we omit this L0, we get L plus. That is L1 union L2 union L3 and so on. Now that we have seen a few of our operations left, let's move on with some questions. L is a language if it has AB, AA and BAA as their elements. Which of the following strings are in L star and in L4? L4 means there should be 4 words from this string. So here the words are AB, AA, BAA. So let's look at the first one. We have AB and then we have AA, we have a BAA and another BAA. So this is L, 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 L. So there are 4 words from this which is being used. So this is a part of L4, and this, since L star is a union of L0, L1, L2 and L4 and so on. This, if it's part of L4, it also implies it's a part of L star. So this is part of both this is part of both L star and L4. Now then this is how you do this type of question. So here it's AA followed by a BAA and then an AA. So again this also belongs to L4. The next one, if we try, we have BAA, AA, an AB and then an AA and then another AA maybe, but there is a B which is not being able to be added anywhere. So this is not part of both L star and L4. And here BAA followed by we can take AA and then an AB and then an AA again. So this would belong to both L4 and L star. Okay, so A, B and D are in L star as well as L4, but C is not there in both. let's move on to another question. Prove that L1 L2 reverse is same as L2 reverse L1 reverse. Okay, so for this let's take few variables. Let U be an element of L1 and then V be an element of L2. So L1 L2 reverse would imply, let's substitute these variables. Let's take UV reverse. So this is a generic string in this language. UV reverse. Now, so UV reverse, for understanding purpose, let's take an example. Let's take U as A, B, A, and then V as B, C. Now, UV would be A, B, A, B, C. Now, the reverse of UV would be C, B, A, B, A. Now CB and ABA. So CB is V reversed and ABA. Now since that is a symmetric word, it's the same as the word itself, and it's the same for reverse as well. From this we can understand that UV reverse can be written as V reverse U reverse. This is V is an element of L2 and U is an element of L1. So this is L2 reverse, L1 reverse. Okay. Hence, now we started with L1, L2 reverse, L1, and then we have ended up with L2 reverse, L1 reverse. Hence, we proved that this statement. Okay. Thank you. We'll look into grammar in the next video.